5.2, use perpendicular bisectors. Well, remember that I said that this chapter had a lot of vocabulary. So here it is. Perpendicular bisector is some sort of geometric figure. Usually it's a line, but it can also be a ray or a segment or a plane that's perpendicular to a segment at its midpoint. Something like this. If I'm going to draw in the midpoint right here, a perpendicular bisector would come up 90 degrees. Okay, equidistance. A point is equidistant from two figures if it's the same distance to both. So if I had a line segment here, I had a point up here, and then I drew in this and measured it, and drew in this and measured it, and they were equal, I could say that that point is equidistant from both of those segment endpoints. Concurrent. 3 or more lines or rays intersecting at the same point. So they're called concurrent lines. Let's go ahead and go back up to my mid-segment equidistant picture up here. If I draw in the, let's call that a midpoint, and that a midpoint, and this a midpoint. If I draw these lines out, do you see that they would be concurrent lines because they intersect at a point? Okay, point of concurrency. I bet you can already know about that. It's the point where they intersect. Okay, circumcenter. Very important word here. Circumcenter is the point of concurrency for perpendicular bisectors of a triangle. Now, things can have a point of concurrency and not be a circumcenter. To be a circumcenter, I have to go back up here to my drawing again and put in that these are all perpendicular bisectors. Then I could call that point in the middle not just a point of concurrency, but I could call it the circumcenter. Alright, theorem 5.2. In a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So C is equidistant. It's on the perpendicular bisector because we know it's perpendicular because of the right angle. We know it's a bisector because both of these are the same. So now we can say that C to A equals C to B, giving us an isosceles triangle. So the converse of the perpendicular bisector. In a plane, if a point is equidistant, so D is equidistant from B to A because of the double hash marks, then it's on the perpendicular bisector of the segment. If DA equals DB, then D lies on the perpendicular bisector. Okay, AC is the perpendicular bisector of BD. Find AD. Well, first, let's go ahead and mark everything we know about this triangle. So AC is a perpendicular bisector of BD. That means that this segment here is the same as that segment, because that's where the word bisector comes from. The word perpendicular comes from the right angle here, so we can draw on a right angle. Now, we also know from the perpendicular bisector theorem that this will equal that. And if you think back a chapter, since this is isosceles, we know that these two base angles are also going to be alike. So, just by knowing the perpendicular bisector, we can tell a whole bunch of things about these triangles. So AD equals AB. Now, we need to substitute in what we know for AD, which is 4x, what we know about AB, 7x minus 6. So, by the joys of algebra, x equals 2. Now, remember what they ask you. They ask you to find the length of A to D. So we have to put the x back in AD. So AD was 4x. So that will be 4 times 2, and that would be 8. Okay, example 2. Use perpendicular bisectors. In the diagram, KN is a perpendicular bisector of JL. So this equals that, this equals that. What segment lengths in the diagram are equal? Well, we know that KN bisects JL, so NJ is NL. Now notice that I don't put the segment marking on top, the little line on top, because I'm talking about measurements of those segments and not the segment itself. Because K is on the perpendicular bisector of JL, then KJ equals KL by theorem 5.2. The diagram shows that MJ is also ML, which they marked as 13. Because MJ is ML, M is equidistance from J and L. So, by the converse of the perpendicular bisector theorem, converse perpendicular bisector. M is on the perpendicular bisector of JL, which is KN. Okay, go ahead and start these 2 checkpoints and start the video again when you're done. Okay, concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. So if PD and PF and PE are perpendicular bisectors, then PA equals PB, which also equals PC. So, this point in the middle is the same distance from here to here to here. Okay? And then notice how you draw that point. You have to start at the midpoint and draw the perpendicular line out, the other midpoint, and draw the perpendicular line out, and the other midpoint, and draw the perpendicular line out. Once you do that, then you have this point in the middle, which would be concurrency, and then you can take this point back to the letters to be the same distance. So example 3, use the concurrency of the perpendicular bisectors. 3 friends are playing catch. You want to join and position yourself so you're the same distance from your friends. Find a location to stand. Well, we want to be on the concurrency, right? So, if I go ahead and draw this in as a triangle, and then I would find the mid-segment of each, and then I would draw in the perpendicular bisectors, and then where they meet, that's where you could stand to be the same distance from this point to A, this point to B, and this point to C. Okay, so you would stand at the circumcenter. Okay, example 3, or checkpoint. Example 3, your friend wants at location A, wants to move the same location, the same distance from everyone else. So find a new position for A. So that'll be kind of fun. Go ahead and pull A around and find a new position. It's actually on the other side of D.